Alhamdulillah, we come back to the second segment of group 7 halogens. Okay, we said we are looking at the chemical characteristics. We said they are reaction with group 1 alkali metal, they form metal halide in it. They form metal halides. Okay, and example we have is sodium chloride, potassium fluoride, okay, lithium iodide. Look at it. How does it look? Lithium iodine is, yes, and sodium bromide. Sodium bromide, and they all be ionic. They all be ionic compounds, and they'll all be dissolved in. They all dissolve in water in it at room temperature, because they are, when they dissolve in water, what happens? They form ions. Look at it. Okay, they form ion. This will be iodide, sodium iodide. Okay, potassium fluoride. When they dissolve in water, they will be found, and they can conduct electricity because of the positive and negative charges. When you, especially when put in electricity, the electrons become vibrate. Yes. Listen. Okay. Now that's what we said. We said they react among themselves to form covalent compounds. Yes, covalent molecules. Yes, when they react among themselves, okay, among themselves or within the group, the right word is within the group. Within the group, okay, bring the camera. Okay, they form covalent molecules. Yes. Covalent molecules. And when they also react with non-metals, okay? And I said again and again, an ionic compound, okay, is reaction between a metal and a non-metal, okay? Always. Because a metal will donate electron to a non-metal, which receive electrons. Okay, potassium, which is a metal in group 1, okay, plus fluorine will give you, potassium fluoride will give you potassium fluoride. Okay, 1, in it, metal and non-metals. But a covalent compound or a covalent bonding is between two non-metals in it. Two non-metals. This example is hydrogen and fluorine. Look at it. Okay, fluorine is 7 in its atomos cell. See, I'm drawing only the atomos cell, okay, and 1 here. It can have a covalent bond with hydrogen. Hydrogen, what is it? Is a non-metal metal? Non-metal. Okay. So,
isn't hydrogen in group 1?
No, hydrogen is not in group 1. Group 1 is only non-metal. That's an exception. Okay, please don't bring that one again. Your GCSE, you just supposed to know lithium, okay, potassium, sodium, and potassium. Okay, group 2 is it beryllium? Yeah?
Magnesium. It has calcium,
Magnesium and calcium.
Yeah.
Okay, group 3, you need to know aluminium, boron, aluminium, copper is used, but you don't need much. Yes,
copper.
That's right. Then here, group 4 is only carbon and silicon. Group 5 only nitrogen and is it phosphorus in it? Yeah. The next group you need to know oxygen and sulfur. The next one you need to know only fluorine, chlorine, bromine, and iodine. And his one you need to know helium, neon, okay, and argon. This is what you need to know. Okay, when we were doing GCSE, they asked us to memorize 20 of these with their atomic mass numbers, with their atomic mass number, not atomic numbers, not atomic mass numbers. We are supposed to know the atomic numbers, okay? We know that this is 3, this is 11, this is 19, okay? Because each time you add 1 in it, yes. 3, you add 8, 11, you add 8, 19. So the next one will be 20, 20? You guys.
27, 27, yeah.
If I didn't put I said X. Exam can come down and I put X here and put Y. Next one. What will be the atomic number of these ones? And they give you all this. And they tell you they're in group 1, in it. Yes, you should say that it repeats itself. One extra cell is added in it. So this one will be 27. This one will be 33. 30? 35. Yes, 35. Okay? Although there's another element in transition element called 35. Okay? I think copper 35 and copper, something like that. Yeah, isotope. There's one which is 35 and 37 isotopes, yeah? Because transition metal, they form isotopes. And we have done isotope, haven't we? Yeah. So you can see, I said covalent bond is the bonding between two known metals. Okay? Look at hydrogen fluoride. Okay? Look at hydrogen chloride, the same thing. Hydrogen chloride, the same thing. Okay? Chlorine, hydrogen. From hydrogen chloride. That's different from hydrochloric acid. When we do acid and bases, you see hydrochloric acid is also this.
You know how potassium 19 and rubidium 37.
Rubidium 37.
Yeah.
Then rubidium may not be the next one.
Rubidium.
Oh, I know why. As you go down here, the cell bit before, this is something you don't need to know. Okay? This is A-level stuff. Okay? As you go down, after potassium, the next one will be 18 electrons. You see, I don't want to mention because I confuse you because I told you.
Oh, because there's 16 after that.
Yes.
16 after.
Exactly. Because I told you each cell, the maximum is 18. But as the atom increases in cells, this is what happens.
16 and 32.
Yes, exactly. Okay? I wouldn't want to tell you all this because I saw somebody, he was saying that, from here, if you look at the periodic table, if you spread the metals, okay, look at the periodic table. Okay, bring it here. Let me bring the camera. If you bring the periodic table, if you count from here to there, it's 17. Okay? They call it period 1, 2, 3, up to 17. Okay? But that is not, in England, we don't take it that way. I think the Indians do. Okay? They even call this thing, the cells, the octets. Okay? Each country have it there. But they call group 7, 17. That's not important. They call group, up to group, okay, 19, 20. I mean the number of cells, okay? That is not important to teach it like that. That's why I didn't mention this to you. Okay? Now, I think we have covered all the chemicals except one. I have to clean this so that I can get more. This one is called displacement. Displacement. And this happens not only in group 7, but in group 1 also. That means, let's look at group 1. Lithium, sodium, potassium. Let's stop at potassium. We said as you go down, what happens to the reactivity? It increases because of the forces that is attracting the last electrons. Okay? It becomes more reactive. So if you have a compound in which you have these two compounds, the one which is more reactive will replace the one that is less reactive. And even that is even evident between group 1 and group 2. Let's say you have sodium chloride plus calcium carbonate. Calcium carbonate. Okay? You will have calcium. Sodium is more reactive than calcium. Cl, yes? Okay? Sodium is more active than calcium. So what you will get sodium carbonate plus what? Calcium chloride, okay?
Yeah.
Calcium chloride. Are these formulas correct?
Make the balances C1, sodium 1.
What is the valency of CO3?
CO3,
CO3, what is CO3 called?
2 minus.
2 minus, yes. What are they called?
The micro ions.
Macro ions.
Yeah.
But they are also called radicals, okay? Another name is radicals or free radicals, okay? They are also called radicals, yes?
So
What?
you need to put 3 in front of the Na.
So Na here,
Yeah, 3.
Here,
2, 2,
2,
2.
yes, not 3. What about here?
The CA is 2, I think.
Ali, what do you think? Ca, calcium is in which group?
It's 2.
Think like this, eh?
2 there.
So the iron will be 2
There,
plus in it.
2 there.
Chlorine is in group 7, so 1 minus in it. So therefore, this will come there, that will come there. So this compound will be CaCl2. Okay? Cl2.
Yeah.
Do you see? You have to, what you call acclimatize. You have to make yourself used to this thing, okay? I deliberately do this thing so that you understand the groups. Okay, by now the 20 elements, you should look at the 20 elements extensively, write it down. Group 1, lithium, sodium, potassium. Group 2, beryllium, magnesium, calcium. You must be used to that. Okay, there are certain elements, you should know them. Okay, aluminium, 3. Okay, so group 1, 1 minus. So group 7, 1 minus, yes? So there's something called displacement, okay? Displacement means